Hi there, Kipsters. It's Mrs. Matthews. Today we're going to be working on Module 4, Lesson 17. The line joining two distinct points of the graph, y equals mx plus b, has a slope of m. Make sure you have this paper in front of you. And then go ahead and scan our objectives for today. All right, let's talk about some prior knowledge we needed to know and a little bit of new information before we get into this lesson. Some things that we've learned from some previous lessons is that slope is going to measure the distance between 2 points on the same line. So you could be given those 2 points, or you may have to fix your values for those 2 points. But we locate a point P and a point R on a line, and then we calculate the distance in between them. That's also known as slope. Something else we've learned in previous lessons is that slope is also known as our rate of change, okay? That's why we're talking about the distance between those points. And we actually abbreviate slope, not with the variable s, but with the variable m. So when we're talking about slope and you have to calculate the slope, you're always going to say m equals some number. We want to try to keep m as a fraction because fractions are easier to plot. Then the new bit of information that you'll be figuring out through today's lesson is we talked about these different forms of linear equations. So linear equations could be written in this form: a times some number plus b times some number equals c, or ax plus by equals c. Today, our second objective is around us taking standard form and transforming it into what's called slope-intercept form. In our first objective, we're proving that when an equation is in this form, slope is going to be the variable m. Okay? We also need to observe and or point out what this variable b means in this equation, and we'll cover that in lesson 18. But b is going to be our y-intercept, or where this line is crossing the y-axis. All right, let's look at exercise number 1. Exercise number 1 says find at least 3 solutions to the linear equation y equals 2x and graph the solutions as points on the coordinate plane. Connect the points to make a line and find the slope of a line. When I see problems like these with all these periods, I like to use the U of cubes to underline how many tasks or prompts I'm going to need to do in this problem. So I see that I need to find at least 3 solutions. That's 1. And I'm going to graph them on the coordinate plane. That's 2. And I'm going to connect them to make a line. That's 3. And I'm going to find the slope of that line. So I actually keep track of which tasks or prompts I've done by putting check marks over them. Let's start with the first task or prompt. Find at least 3 solutions to the equation y equals 2x. Well, I know that when I want to find the solution to any equation, I want to fix either my x variable or my y variable. So I've been given the linear equation y equals 2x, board equals paper. I want to fix my variables for x to be some simple numbers to work with. Let's start with 0, 1, and 2. All right, now we have some steps that we use to work down any equation. You want to make sure that step 1, you write the equation as given. In step 2, you'll notice I'm dropping off this y equals. Now I am going to write the equation, except this time I'm substituting my given variable of x. For everywhere I see x, I see 1x. I'm going to substitute in 1, 0. And let's attend to some precision. Let's bring that equal sign. All right, continuing to work down vertically so I can see how this equation is transforming. I'm now going to compute. I'm going to do this math. 2 times 0 is going to give me 0 because anything times 0 is 0. And I have no more work to do. That means I found my value for y. So when x is 0, y is 0. I found 1 solution to the equation. Let's continue to find 2 other solutions. So step 1, I want to write the equation as given. What do I want to do in step 2? Yeah, I want to substitute as given. I want to substitute as given. But instead of putting a 0 this time, I want to substitute in a 1. Now I'm going to compute. I'm going to do that work. I'm going to handle the multiplication. 2 times 1 leaves me with 2. So therefore, when x is 1, y equals 2. I found my second of the 3 solutions. Let's work with number 2 when x equals 2. What does y equal? Well, I've written my equation like I've been given. Now I'm going to substitute my value of 2 for the variable x. Going to compute, and I get that 2 times 2 is 4. So when x is 2, y is 4. I have 3 solutions. Now I'm ready for my second prompt. I want to graph these solutions on the coordinate plane. Directly to the right, you have a coordinate plane. It's made up of x-axis and y-axis. Okay, and I want to plot 0, 0, 1, 2, and 2, 4. It's a good idea when you're plotting on any points on the coordinate plane to start at the origin. The origin is where x and y meet. All right, and if I want to go to an x of 0, I want to go left or right until I hit 0. And same thing with the y. I want to go up or down until I hit 0. Lucky for me, my first point is actually at my origin. So I'm going to go ahead and place that point. Put a check because I've graphed one solution. Please graph your remaining 2 solutions. Make sure you have 2 check marks at the top. Alright, so I have graphed all of my solutions, have my 3 checkpoints. I've connected the points to make a line. And now I'm on my last prompt. I want to find the slope of that line. There are some ways I learned to calculate slope in a previous lesson. Type one of those ways in the box. Hopefully you said, to calculate slope, I'm either going to count on the graph from one point to the other. I can use the slope formula where I'm identifying points P and R and I'm taking the difference of them and then dividing them. Or I can use similar triangles or slope triangles to count from one point to the next. Whichever way you're doing, please calculate the slope of this line and type your answer in the box. So I see to count on the graph, I want to move up 2 and to the right 1. When I move up 2 and to the right 1, I'm left with the fraction 2 over 1, which simplifies to 2. Therefore, slope is equal to 2. Now, rewatch that if you need. Otherwise, let's go ahead and push into exercise number 2. Exercise number 2 asks you to do the exact same thing. You want to find at least 3 solutions to the equation y equals 3x minus 1 and graph those solutions as points on the coordinate plane. Make sure you connect the points to make a line and find the slope of that line. So there is 1 task, 2 tasks, 3 tasks, and 4 tasks, just like the previous problem. Please, let's go ahead and fix our values of x, 0, 1, and 2. And let's get our linear equation written here in the middle. Please find the value of y when x equals 0. Well, when I substitute write my equation is given, substitute my value of 0 in, compute. How do I know I need to do this math before I subtract 1 from anything? What tool should I be using? Yeah, I should be using PEMDAS, which tells me I'm going to handle multiplication and division before I handle addition or subtraction. So I'm going to do 3 times 0, which gives me 0. Then I'm left with 0 minus 1. Because there's no more work to be done other than that subtraction, I know that y equals negative 1. I found one solution. When x equals 1, what is y? When x equals 1, y is 2. Take a look at the steps in order. Once you agree, make sure you have your your second check for your solution. Lastly, what is y when x equals 2? When x equals 2, y is 5. When x equals 2, y is 5. So you should have 3 check marks now over 5, 3 solutions. Let's move to the next point or the next task. I want to graph these solutions as points on the coordinate plane, connect the points to make a line, and find the slope of that line. 0, negative 1, 1. Make sure you always use your straight edge, your ruler, or a piece of paper to connect your points. You'll notice I went a little bit above the line and a little bit below the line. Now use one of your three methods from the previous problem to tell us what is the slope of this line. Here I'm going to use a different method this time. I'm going to calculate. So let's say I label this as point P and this as point R. My formula to calculate slope is P2 minus R2 over P1 minus R1. I want to substitute what my values are. So I see that P, making this ordered pair be P. Sorry, you couldn't see my paper. And this ordered pair be R. So this is our P1, remember? And this is going to be our P2. This is going to be our R1. And this is going to be our R2. So I'm doing 2 minus 5 over 2 minus 1, numerator to denominator. I want to do the math in my numerator. 2 minus 5. 10 to precision, I'll use this calculator. 2 minus 5 gives me a negative 3. Clear everything out. 2 minus 1. Sorry, I did that backwards. It should be 1 minus 2. There we go, 1 minus 2. When I do 1 minus 2, I'm going to be left with a negative 1. All right, I know when I get to this point, I'm almost done. Remember, when I see two negatives being divided, I know I'm actually ending up with a positive. So slope is going to equal 3. All right. Exercise number 3. Find at least 3 solutions to the equation y equals 3x plus 1 and graph the solutions as points on the coordinate plane. Connect the points to make a line and find the slope of that line. Go ahead and begin to follow these 4 prompts, putting 2 minutes on the clock. All right. So this is what your graph should look like when x is 0, y is 1, when x is 1, y is 4, and when x is 2, y is 7. The slope of this line is going to be m equals 3. So now let's take a look back at the last few problems we've done in exercise number 1, and I'll put them in a table here. So you had exercise number 1 where you had this equation, and slope was 2. In exercise number 2, you had this equation, and slope was 3. And in exercise 3, you had this equation, and slope was 3. What do you notice about the equation y equals mx plus b and the slope? Pay close attention to the numbers. Yeah, you should notice that in each graph and or equation, the number that's attached to my x is going to be my slope. Let's apply this a little more concretely. Go ahead and find exercises 4 and 5 and tell us what that slope would be. Yeah, the graph of this equation, y equals 7x minus 3, slope is going to be m equals 7. Slope in number 5, what's our slope going to be? Yeah, in the graph of the equation, y equals -3 over 4x minus 3. Even though it's this funky looking fraction, I want to look at the number, the coefficient attached to the variable x. So I know that my slope is going to be -3 over 4. Sorry, don't bring the variable with it. Slope is just the number attached to the variable x. All right, we talk about slope to begin to make word problems look less scary for us. And not necessarily talk about slope. We talk about this equation form, y equals mx plus b, to help us begin to get linear equations onto a graph and better examine them. When we are doing any word problem, what's the tool that we use to annotate our work? You have cubes. So you want to make sure you want to make sure that you're underlining the questions. B, you want to box out any math action words. E, evaluate what steps you should take. And S, solve and check. Does your answer make sense? And how can you double check? We'll use cubes to help you with number 6. Number 6 says you have $20 in savings in the bank. Each week, I know each week is going to be something because each is a word, a convention, an operational word for multiplication. Each week you add $2 to your savings. Let Y represent the total amount of money you've saved at the end of X weeks. Write an equation to represent this situation and identify the slope of the equation. What does this number represent? So I see 3 underlines that lets me know I have 3 prompts or tasks in this problem I need to complete. I've circled all of my important numbers. I've underlined my questions. I have boxed out any operational words. See if you could find the words that would represent our equal sign. Yeah, so it's letting Y represent the total amount of money. So Y represents the total amount of money. I'm going to go ahead and box it out and put in an equal sign around it. So let's use some words to build up this equation. So I know I'm going to have something on the left side. I know I'm going to have something on the right side of this equal sign. So I'm going to put my equal sign down on the paper. What do you think is going to go on my left? What am I starting with? What does this look like? Well, I know I'm starting with some savings, so I got my starting savings. Okay. Then it says each week I add to my savings, so I have this starting savings, and I'm going to add to it. What am I adding to that? I'm adding $2. So I got the amount saved weekly. And then each week, how would I show each week me saving $2? Yeah, I'm going to use the operation of multiplication. I use multiplication. So I would say the number of weeks. You can zoom in and slow down. Click continue when your paper looks like mine. All right, now I'm going to move on to the right-hand side. What's going over here on the right? What do we annotate for our equal sign? Y. Y is going to represent the total amount saved. So I have that what I started with plus the amount I saved weekly times my number of weeks is going to be equal to the total amount I saved. Let's pull out those important numbers and put them under the parentheses that group them. Sorry, my savings is $20. Adding that to each week. Not sure how many weeks I'm going to use my variable of X. All right, and that's being multiplied by my amount saved weekly, and I switched how I wrote them down. My apologies. The amount I saved weekly is $2. That's going to be equal to my total amount saved. I go to the problem. The total amount saved is represented by Y. Kind of looks like this equation. But let's turn it around and clean some things up. So let's lead with our Y equals. So Y is equal to, and I can actually just write this going backwards. 2 times X plus 20. what would the slope of this equation be? Yeah, slope equals 2. What is this number going to represent? Slope is going to represent the amount, say, cool. Problem 7, 8, 9, and 10 work in a similar fashion. Please make sure you're using cubes to get through these problems and type your answers in the boxes as they pop up.